This video will discuss the properties of isosceles triangles. Remember that isosceles triangles have at least two congruent or equal sides. The parts of an isosceles triangle have special names. So we want to remember there's at least two congruent sides. The two congruent sides are called legs of an isosceles triangle, and the angle with the sides that are the legs is called the vertex angle. So our vertex angle would be here, and our legs are here. The side of the triangle opposite the vertex angle is called the base. So our base angle is going to be, base side is going to be that one right there. The two angles formed by the base and the congruent sides are called the base angles. So our isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So we could say if we know that AC here equals BC, then angle 1 is going to equal angle 2. Conversely, if two angles of the triangle are congruent, so if 1 and 2 are congruent, then we can say that the corresponding sides, the sides opposite those angles, are congruent or equal as well. Let's take a look at an example. Name two unmarked congruent angles. So if we have that these two sides here are equal, then we know that the base angles are also going to be equal. So our base angle ACB, and the other one would be and angle ABC. Name two unmarked congruent segments. So since we know that angles D and C are congruent, by the converse we can say that AD and AC are equal to each other. So AD and AC. Now let's take a look at the proof to show how we know this. To prove the isosceles triangle theorem, we'll draw an auxiliary line. So an auxiliary line would just be this line right here, an extra line that we draw in the figure, and use the two triangles formed. So the first step is let N be the midpoint of MP. So we'll say N is the midpoint. We'll draw an auxiliary line segment LN. Any 2 points determine a line. And by definition of a midpoint, we can say MN equals PN. So these two are going to equal each other. And LN is going to equal itself by the reflexive property. They already told us that LM equals LP. So this side equals this side. So that was given. And then we can say triangle LMN is congruent to triangle LPN. We can do that based on side, 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 because we have all three sides. 1, 2, and 3 that are equal to each other. So if all three sides are equal to each other, we can call those congruent triangles. And because corresponding parts of congruent triangles are equal to each other, we can say that angle P and M are equal based on CPCTC.